Good evening, everyone. Let us start with a new video today. So if you remember, for the past 3-4 days, we are working on rotation and some of the problems on rotation. So let me just recap what we have done so far. Just a moment. I hope my screen is shared. Okay, so in the first video, I think we looked at about identifying the correct parameters, about finding out what is the angular velocity and what is the angular acceleration based on the given values. And in the second video, we looked at, okay, when can we use uniform motion and when can we use equations of motion, accelerating motion. That's what we have seen. In the third video, we have seen about how to calculate the radial and tangential acceleration. And then the fourth one, there's a lengthy calculation that needs to be worked out and how to correctly identify and what is we need to give importance here. So we need to give an importance to the axis when we talk about the moment of inertia and especially in rotation level problems. Now the current video, the fifth video, speaks about the center of mass. Okay. Now, before we start with the rotation, in the previous few videos, we had learned something about the center of mass. As for example, when I have a spherical object, what we do is we consider the center of mass is to be located at this point. That's what we did. Now, this problem is based on this, so which tells you something like this. It tells you that find the moment of inertia of a pair of spheres. So I have two spheres, and the radius is same and they're kept in contact about the tangent passing through the point of contact. Okay, so it's something like this. So this radius is r, and the mass of each sphere is m here. It is asking you to find out what is the moment of inertia. Now, if you want to find moment of inertia, my student, what he had done is center of mass of both the spheres is separated by 2r. So he considered something like this mass of the sphere. This mass can be considered to be having a center of mass at the center. Good. Center of mass for the first sphere is here. Center of mass for the second sphere is somewhere over here. The distance between them is 2r. And then in between, this is the perpendicular bisector, which is the center passing through it. So we want to find out what you call the moment of inertia about this axis. So this is mass m, this is r once again, this is mass m. So he got the answers 2mr square. Now, do you think this is correct? It's completely incorrect. Why incorrect? The reason is because when you alter the center of mass, then you observe that the moment of inertia will also get altered. Now, how do I know this? If you ask me this question, what is center of mass? It is a place where the entire mass is said to be focused. Now, let us say, for example, I take up a sphere. Now, in the sphere, if I cut this into half, which is a hemisphere. Okay. Now, this hemisphere will be like this over here. It will be like this over here. Now, where is the center of mass for this one? Center of mass will be somewhere over here. Now, if I make an axis pass through this one, through the center of mass, it will have a different moment of inertia. Okay. Now, if I keep an axis like this, if it passes like this, okay, it will have a different moment of inertia. So this moment of inertia will change with the center of mass over here. So it is not same for the same center of mass. So as a result of it, changing the center of mass will change the moment of inertia. So as a result of it, you should not approximate this one to center of mass. So therefore, this concept is incorrect. Okay, you cannot use the center of mass concept in determining the moment of inertia for a complex system of objects. Okay, or an extended system of objects. Is this clear? Okay, now let us continue with this. Now, solution is very simple. It's a straightforward problem. So center of mass, okay, you want to find out what is the moment of inertia for two spheres like this. Now, what we do is the moment of inertia of the sphere with respect to a line passing through this one, through the center of mass, through the axis. If it is passing like this, if it's a solid sphere, then I will say this is 2y5 mr square. This is your I0, right? Now, what is the moment of inertia of this sphere with respect to this? Then we say this distance is r. So as a result of it, moment of inertia of the first sphere is I1 will now be equal to I0 plus mr square. What is this now? This is nothing but your parallel axis theorem, right? Where I0 is nothing but the moment of inertia about the center of mass, And this is the axis which is passing through a line which is parallel to the center of mass axis. Okay. So therefore, now let me write this 2 by 5 mr square plus mr square, which should be equal to 7 by 5 mr square. Now there is not only one sphere, there are two spheres over here. So what will happen? The total center of mass, sorry, total moment of inertia will now be equal to 2 times I1, which will now be equal to 14 by 5 mr square. Right? 5 plus 2, 7, 14 by 5 mr square. So thus the net moment of inertia is seen to be 14 by 5 mr square. Thank you friends for watching this video. If you like this, do share and subscribe to my channel for more updates like this. This will really help me out, okay, in deciding, or if you can also comment about what kind of videos you like, it will really be helpful for me to think about, okay, what kind of videos can be added. Thank you.